All right, with question number 4, they give you a circuit and they say that R1, 2 and ohm 6 is connected in series, and R1 and 2 has no internal resistance in this circuit. They want to know what is R1 and 2's values if the following is given. So they give you this. They give you that the reading on V12 or V1, that's the one that's connected basically over the battery, is 18 volts, and that V2 over here that's connected over the two unknown resistors is 12 volts. Okay, so this is just basics. It's a normal grade 10 question, meaning that this is our V total, so everything should be provided to the whole circuit. So if we have V2 here, and if we connected another voltmeter here, say V3, it should have had a 6 volt, because 12 plus 6 should give you that 18. So everything is equal, okay? So if we can see that the voltmeters over R1 and 2 is 12 volts, that means if one is 6 volt, both of them R1 should equal R2, and both of them should equal a value of 6 ohm, and that is your correct option, option B. Okay, so with number 6, you'll see if you have a circuit over there that they give you that this circuit has an EMF as well as an internal resistance, because we have that dotted line over the battery as well as that small r inside of the dotted line. Alright, and then you'll see we have a part, we have two series resistors, R and R, and then we have a switch connected over R. And then they want to know what happens with the voltmeter and the ammeter reading if we close that switch. So the moment that switch is closed, we get a bypass. So we're skipping that resistance, because remember, current flows where there's less resistance. Okay? So the moment we close that switch, our R total decreases. Okay? So if switch S closes, R total decrease. And we should know that I is inversely proportional to R. So that means that our I total will increase. And together with that, you should know that VI will increase, because now the battery works harder. Okay? So, and out of our EMF formula, we know that EMF is constant because we didn't change anything on our batteries. So VI increases, meaning our external volts should decrease. So we're looking for that, and we're looking for that. So our correct option will be C, where our ammeter reading increases and our external volts, our potential difference, decreases. Okay, with number 16, I'm going just quickly going back. Number 16, they give you this circuit. I just drew it on the whiteboard, and they're saying that R1 is smaller than R2. We do not have internal resistance, and then which option is then correct? Okay, so with number 16, we have this. So I'm going to use my own values, because my mind works better when I see values. So then we can check this then. So if you go and look there, that if we use values of 12 volts to be our total potential difference, there's no internal resistance, R1 is smaller than R2, that means that the voltmeter readings should be that. Okay, so if you want to go through your options, you'll see that basically what we have here is that V2 is bigger than V1. That's easy, but you'll see there's no option like that. They say that V1 is bigger than V2. But what is true with a series circuit when we do not have internal resistance? What is true is that the current flowing through there is equal. Okay? So if we look at our triangle, we know that our current is calculated V over R. So that means that the voltmeter reading of 1 over R1 should be the same to V2 over R2, because that is then calculated as our I total. And that is what you had to go and look for. It was a bit nasty. So if you don't know your formula, you won't know what current is. So the correct one here is option C. Okay.